Episode 2 of Prime Puzzle. Let's get to it. A boat racing competition was held at Hussain Sagar Lake in Hyderabad, in which a total of 10 boats participated. Two ends of the lake, A and B, were tagged as start and reverse respectively. Okay, so let us try to draw it. It looks something like this. This end is A, this end is B, this is the reverse point. Okay. Uh, the starting point of the race is end A, which is also the finishing point of the race, such that each boat has to start the race from A and then row to the other end B of the lake and then row back to A. So every boat is moving this way. Every boat is going this way. Okay. All the 10 boats started from the end A at the same time. Some of the data related to the race is also known. The distance between the two ends of the lake was 2 kilometers. Okay. Speeds in kmph of all the 10 boats were different from each other, but the speed of each boat remained constant throughout the race. Okay, so 10 different speeds. The distance from end A at which two boats were present at the same time is called the meeting point. Okay, so when the faster boat is returning, it will of course meet the slower boats in return. So that is known as a meeting point. That is known. Find the number of meetings for all the boats taken together at the meeting points during the race. Okay. So now for the fastest boat, let's call that boat 10. The fastest boat, boat 10, will meet with 9 other boats. While returning, it will meet 9 other boats. So there are 9 meetings here. Similarly, boat 9, when it is returning, I'm only caring about the meeting points while returning, because boat 9 and boat 10 would get counted within one of these 9 meetings. So boat 9, when it is returning, it will meet 8 other boats. So 8 meetings. Boat 8 would meet 7 other boats. So 7 meetings. Hopefully by now you have seen a pattern emerging. Your first boat has 9 meetings, second boat has 8 meetings, third boat has 7 meetings. This is the fastest boat, this is the second fastest boat, this is the third fastest boat, and so on. So can I say total number of meeting points would be nothing but the sum of first 9 natural numbers, which is given by 9 into 10 by 2. Cancel. 5 should be 45. So option 4. Sorry, why have I mentioned option 4? Option 3, 45 should be the answer. Next, find the minimum possible number of meeting points in the lake. Now, this is where this question turns into a quant question rather than a DILR question. And it is amazingly fun. This is basically testing your concepts of time, speed, distance. So let's see. I know, let me draw a line all over again. This is A, this is B. I know that boat 10, or the fastest boat, will definitely meet 9 other boats. And given that all speeds of all the 10 boats were different, it will meet 9 other boats at 9 distinct points. This is guaranteed. The fastest boat will meet all other 9 boats at 9 distinct points. This is guaranteed. So now what I want is, if I want the minimum possible number of meeting points in the lake, those meeting points are going to be defined by ratio of speeds of boat. Ratio of speeds of boats. So let's say the fastest boat was 2. Fastest boat, or boat 10 as we had dubbed it, has a speed of 2, and boat 9 has a speed of 1. So I'm dividing this entire path into 3 parts. In the time that the fastest boat would have traveled 3 parts and returned 1 part, boat 9 would have traveled 2 parts. This is for boat 9, this is for boat 10. Boat 10 has traveled 4 parts of the journey, boat 9 has traveled 2 parts of the journey because the ratio of the speeds is 2:1. At this point, a meeting is definitely taking place. Now, if I want to ensure that the minimum possible number of meeting points take place, what I would also want is speed of boat 8 to be in the same ratio, speed of boat 8 to be in the same ratio as the ratio of boat 10 and boat 9 speed. So let's say speed of boat 8 is 0.5, speed of boat 8 is 0.5. So the ratio of 2:1 and 2:1 is maintained. By the time boat 9 travels this path, travels 4 parts, boat 8 would have traveled, boat 8 would have traveled 2 parts. And now this meeting point which we had identified for 10 and 9 is also the new meeting point for boat 9 and boat 8. It would also be the meeting point for boat 9 and boat 8. So can you see, if I want to repeat the meeting point, I have to repeat the ratio of speeds, whatever I had for boat 10 and boat 9, I had assumed the ratio to be 2:1. If I want to repeat the meeting point, I want the ratio speed of boat 9 is to boat 8 to also be 2:1. I want the ratio. If the ratio of speeds is repeated, the meeting point is also repeated. Now extending this further to a large extent, what I can essentially do is, I don't think I have space left here. What I can do to a large extent is, 1 minute, I'm going boat 10, boat 9, boat 8, boat 7, boat what? Boat 6, boat 5, boat 4, boat 3, boat 2, and boat 1. So if this is one, okay. I'm putting speed of boat 10 as 512. You'll see why I've got with 512. Boat 9 is 256. Boat 8 as 128. Speed here to be 64, 32, 16, 8, 4, 2, and 1. Basically, I want it to be in a GP. I want the speeds of boats to be in a GP, because see, now whatever meeting point you want to have, the ratio of speeds can be replicated by boat 10 is to something. Let's say I want to look at meeting point of boat 7 and boat 4. The ratio of their speeds is 64:8 or 8:1. I can get a ratio of 8:1 with boat 10 and boat 7. 512:64 is indeed 8:1. Or let's say I wanted a ratio of boat 8 and boat 2. I see the ratio of the speed is 128:2. 128:2 or 64:1. If this is what I need, I can replicate the ratio with boat 10 and boat 4. 512:8. The ratio of speeds will now be 64:1 all over again. Basically, the 10 meeting points that we had generated for the fastest boat, the 10 meeting points that we had generated for the fastest boat, those are the same meeting points that all other boats will also meet at. So what will be the minimum possible number of meeting points in the lake? The answer has to be option 4, 9. We don't need to have any more distinct meeting points. Okay, moving on. Next question. If the meeting points in the lake were minimum possible, which is a different way of saying speeds are in GP. Speeds are in GP. If the meeting points in the lake were minimum possible and the speed of the fastest and the second fastest boats were 10 km per hour and 8 km per hour. So if boat 1 is 10, sorry, fastest boat is boat 10, has a speed of 10. Boat 9 has a speed of 8. Can you see the first two terms of the GP are given and therefore the common ratio is 4 by 5. So I can now get boat 8, 4 by 5, how much will it be? 6.4. And then boat 7 will be 5.12 and so on. Boat 6 will be 4.096. Okay. Then find the speed of the boat having the fourth highest speed. Fourth highest speed was for boat 7. The speed for boat 7 will be 5.12 kilometers per hour. Final question. If the meeting points in the lake were minimum possible, which is a different way of saying speeds are in GP, then at which meeting point will there be exactly 5 meetings? Meeting points are marked from A to B in that direction. Okay, let's see. I'm going ahead and writing down the 9 meeting points. So 1, meeting point 1, meeting point 2, meeting point 3, meeting point 4, meeting point 5, meeting point 6, meeting point 7, meeting point 8, and meeting point 9. Kindly pay attention, they will not be as equally distributed as I have represented them in this linear line. It is just that it makes for better representation, nothing else. Now at this meeting point 9, because the speeds are in GP, at meeting point 9, we will have how many meetings? 10 and 9 will meet here, 9 and 8 will meet here, 8 and 7 will meet here. All these boat numbers, these are all boat numbers. And 7 and 6 will meet here, 6 and 5 will meet here, 5 and 4 will meet here, 4 and 3 will meet here, 3 and 2 will meet here, 2 and 1 will meet here. So at meeting point 9, how many meetings are we getting? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 meetings are taking place. At meeting point 9, 9 meetings are taking place. When we get to meeting point 8, boat 10, boat 8, boat 9, boat 7. And if we keep on going, the last pair that meets here will be boat 1 and boat 3. How many distinct meetings take place at meeting point 8? 8. Hopefully by now you have seen a pattern emerging. At meeting point 9, you have 9 meetings. At meeting point 8, you have 8 meetings. At meeting point 7, you will have 7 meetings. At meeting point 6, you will have 6 meetings. At meeting point 5, you will have 5 meetings. Which 5 meetings, if you ask, it is going to be boat 10, boat 5, boat 9, boat 4, boat 8, boat 3, boat 7, boat 2, and boat 6, boat 1. At meeting point 5, these are the 5 pairs that will be meeting, and therefore answer to the question would be option 1, 5th. Let's go. Next question now. All courtiers in the court of emperor have a few gold coins with them. The courtiers have been divided into total 8 groups according to the number of gold coins they have as follows. Okay. They have been divided into different groups. Interpretation of the table. The number of gold coins with all the members of the group 1 is between 1 and 10, both inclusive. Okay. G1 has at least 2 members. One of them has 1, one of them has 10. There is at least one member having 1 gold coin and at least one member having 10 gold coins in group 1. Other entries in the table are also similarly interpreted. So for each of these groups, every group has at least 2 people, and among those 2 people, at least one person is at the lowest value and at least one person is at the highest value. Okay, wonderfully done. It is known that the number of members in each group cannot be more than 10. Okay, we cannot have more than 10 people in each group. The number of members in different groups can be different. The exact number of courtiers is not known. Okay. First thing is, if there are 40 courtiers, then what can be the maximum average number of gold coins with the courtiers? Okay. Now pay attention. We know that each of the number of members in this group is 2 at each of these places. At least 2, 2, 2, 2. So can I say 16 people are already accounted for? 16 people are already accounted for. And for these 16 people, what will be the average? You don't need to do any maths. You can straight away go minimum value, maximum value, and the average of that. So 16 into 40.5 is straight away no. 16 into 40.5 is straight away no. You don't need to check any further. 16 into 40.5 is straight away known for the simple reason 1 and 80. The data points here are distributed. Can I say 1 and this will be the average for the 2 people that are here will be 5.5. The average for the 2 people that are here would be 15.5, so on and so forth up until 75.5. So now if you take the average of these two, you're going to get 40.5 only. This is done. Now my objective was to maximize the average. So if I want to maximize the average, I would want people who have more gold coins. So the next 8 people that I introduce, and why 8? Because no group can have more than 10 people. The next 8 people that I introduce will be in G8 and all of them will have 80 coins. All of them will have 80 coins. Okay. So far, how many people have been taken care of? 24. The next 8 people that I introduce will be in G7 and all of them will have 70 coins. 32 people have been taken care of. And the next people that I introduce, next 8 people that I introduce will be from G6 and all of them will have 60 coins. So I now have the total number of gold coins present, but we are not really looking for total number of gold coins. We are looking for average. So we'll have to divide this whole thing by 40. Okay, let's go ahead and divide it. While dividing this, hopefully you can see, instead of working with 16 into 40.5, it would be much easier if we worked with 8 into 81. Our life would be simpler. 8 into 81. So, and 8, I can cancel off from each of these groups. So 8 gone, 8 gone, 8 gone, 8 gone. And we are left with 5. We are left with 5. Now, for these 3 numbers, it is now all you have to do is 16.2, 16, 14, and 12. If we add them up, we reach 58.2. The average is conveniently reached. The question, the options here, more than 58 but less than 59. Option 2 will be our final answer. You did not have to multiply numbers and get to a large value and then work your way down. If you understand averages, you could have done this process far, far smoother. Next question. If the number of members in all the groups is more than 2, okay, none of the groups have 2 members now, every group has more than 2. And within each group, the number of gold coins with the members of the group form an arithmetic progression with a common difference more than 1. Then what is the average number of coins with the courtiers? Wonderful question. Look at this. We are first looking at G1 only. You have member 1 having 1 gold coin, and you have some other member, let's call this member n, having 10 gold coins. Now this is a first term of an AP, and this is a plus nd. 10 is a plus nd, which means the gap between them, the gap of 9, is nd. nd is equal to 9. nd is equal to 9. Additionally, we have been told that n has to be greater than 1, has to be greater than 1. The only way you can represent 9 as a product of two positive numbers is 3 into 3. 3 into 3 is 9, which would mean there are two people in between. There are two people in between. You have 1 here. Member 2 will have 4 gold coins. Member 3 will have 7 gold coins. And member 4 will have 10 gold coins. So for G1, there are 4 members and all of them have 1, 4, 7 and 10 coins. All conditions met, everything is done. Now the beautiful thing is, once you're done with this, you know the answer will now be 40.5. Ideally, you should know the answer will now be 40.5. Because whatever processing we have done for G1, can you see the exact same processing will also happen for G2? Because nothing materially is changing. It is just that every value will increase by 10. So if it is 11 to 20 now, it will now be 14 here, 17 here, so on and so forth. So for every group, group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8, every group will have 4 members, and the common difference at each place, is equal to 3. Now the average for group 1 is 5.5. Again, we are going down this route, if you notice. Average for group 1 is 5.5. Average for group 2 is 15.5. Average for group 8 is 75.5. And this is an AP with a common difference of 10. This is an AP with common difference of 10. If I need the average of this AP, it will be 5.5 plus 75.5 by 2, which is equal to 40.5. And therefore, the answer to the second question will be option 2, more than 40, but less than 41. Okay, moving on, next question. For the next two questions, there was additional information. The emperor appointed a council of advisors consisting of 1 member each from each of the 8 groups. Okay. Now we have 1 member each from each of the 8 groups. The average number of gold coins with the members of the council of advisors is 43. 8 members, average 43. After 2 months, the emperor dropped 1 member from the council, because of which the average number of gold coins with the members of council became 47. Now see, I'm sure you can do it. 8 into 43 minus x divided by 7 is equal to 47, and you can solve for x. I am very, very confident you can do that. And I'm guessing most people would have done it that way. What I want to bring in here is the idea of deviation. If you work with deviation, you wouldn't have to even write that equation. You wouldn't even have to write that equation. Now see, if a member has been dropped and it leads to increase of average. If a member from the group has been dropped and it leads to increase of average. Increase of average would imply here that the member that has been dropped was lower than the average. When a value lower than the average is removed from the group, the average of the group increases. The average of the group has increased by 4. For how many people who are left in the group? 7 people. The average of the group has increased by 7. Sorry, the average of the group has increased by 4 for 7 people. So the person who was eliminated had these many coins. He had a deficit of 28. he had a deficit of 28 from the average. So when he leaves, that deficit is now gone. And therefore, that person who is leaving the group had 15 coins with him. The person who has been dropped from the council had 15 coins with him. And if you had 15 coins, which group are you a part of? Definitely G2. To which group does the member who was dropped from the council belong? He was definitely a part of G2. The other way, as I spoke, was of course 8 into 43 minus x divided by 7 is equal to 47. If you're comfortable with maths in this, you can go ahead and do that. I am not. I don't like doing maths this way. This is problematic for me. So in fact, even here, even within this maths, can you see you could have gone down the root of 8 into 43 minus 7 into 47 is equal to x, or 8 into 43 minus, sorry, 7 into 43, 43 plus 7 into 43 minus 7 into 47 is equal to x, which if you take further, it will become 43 minus 7 into 4, which will eventually lead you to 15. I'm saying you could have avoided this working by directly thinking of assumed mean, Okay. Next thing, let us look at this portion. There was additional information in the question. The very next day, the emperor appointed 3 other members to the council, after which the average number of gold coins with the members of the council became 40. Again, I would prefer, you can do it equation wise. I'm sure most people would have done it equation wise. I want to introduce the idea of deviation. So I'm saying these members, after their inclusion into the group, have brought the average down. These members, after their inclusion in the group, have brought the average down by how much? They have brought down average for 10 members by 7. The average originally was 47 and 3 members are coming in. So had they come in at 47 itself, this is how much they would have contributed. But they are bringing the average down by 7 for 10 members. So these 3 members have a total of 71 coins with them. You can get to this result in one line. You don't have to do this. 47 into 7 plus x upon 10 is equal to 4 is equal to 40. Although this is still manageable, I prefer working with deviation because it is efficient regardless of what case you take. In this case, it is becoming easier because it is 10 into 40. These two numbers are very kind to us. Any which way, we now have 71 coins. The 3 people that have come in, they have a total of 71 coins with them. So the last question, to which groups can the 3 new members of the council belong to? 2 from G2 and 3rd from G3. 2 from G2 and 3rd from G3. Can you see, even if you took the highest people from G2, 20 and 20, and the highest person from G3, 30, we would have 20, 20, 30, which is still lower than the required 71. So not possible. Let's look at this. All 3 from G2. If 2 from G2 and 3rd from G3 is not enough, even if I took the maximum people, all the people from G2 to be the highest possible, 20, 20, 20, this is still not good enough. Let us look at the second option, 2 from G3 and 3rd from G4. Okay. So I'm saying instead of taking maximum this time, I'm taking the smallest possible range. If I took 2 from G3, 21, 21, and 31 here, can you see that the minimum, even if you took this group of people, the minimum possible total that you would reach is 73, which is more than the 71 that we desire. So this is also wrong. And finally, we are left with G3. And now you can see if I had taken 23, 24, 24, yes, I've got 3 people from G3. A smarter way of doing this, wherein you wouldn't have to check every case, would be simply where is the average of this coming out to be? Can you see the average of this is 23.66? Average of this is 23.66. So now when you are running through these options, you can happily see 23.66 lies within G3. Can I have all three members from G3? Yes, you would have directly marked this option and moved on. The bigger clue present within the question that gives you the indication that you have to check options is language of the question. To which group can the three new members of the council belong to? Whenever the question says can, it means there is no precise answer. You have to check every option individually, which if you would have done here, your life would have been simpler. That will be all, people. Thank you very much. See you in episode 3. Bye bye.